So next type, so centrifugal governors we have stopped, and now we are going to deadweight type governors where we are going to use. So this watt governor is very sensitive. So I want to do some calibration of the watt governor and make it a little bit more stable, so that with each RPM it does not change like that. For change in 1 RPM, the governor sleeve lift change in height is 8 millimeter. That's too much. Okay. So we are going to make it a little bit less sensitive by use of a weight that is placed on the sleeve. You are lifting the sleeve, and I'm going to add some weight onto the sleeve. The lift is going to get slowed down. Okay. So Proter Governor. The Proter Governor is a modification of the watt governor with a central load attached to the sleeve, as shown in figure A below. Okay, so it's exactly very similar to a watt governor. Only difference is you have this a load sitting on the top of the central sleeve. So when your ball is going to lift the sleeve, as in a watt governor, you have to lift it along with this central load. The load is calculated and placed in such a way that this upward and downward movement of the sleeve is stable. It is not too sensitive. Okay. Consider the forces acting on one half of the governor shaft. As I told earlier, it's a mirror image. It's very symmetrical. You can analyze only one half of the forces. It is enough. Okay. So therefore, the forces acting on this ball B, the centrifugal force is going to act outwards. Now, to balance this, we are going to have some tension in these two arms. Correct? These two are going to stop this ball from going out. We are going to have two tension. So what is the primary difference between watt governor and this type of governor is that if you see here, earlier both the upper link and the lower link were connected to the axis of the governor. Here it is kept a little bit away from the axis. Okay. So therefore what happens? This angle is different from this angle. This is alpha, this is beta. Now this is going to create some complications. We are going to see what are all those complications, how to solve that. So M is the mass of the ball, W is weight of the ball, capital M is the central mass, the central load W sitting on the sleeve, and W is its weight, R is radius of rotation in meters for a given RPM, H is height of the governor, N is speed of the ball in RPM, omega is angular speed of the ball in radians per second, and Fc, this C should be in suffix. Below, not like this. So Fc equal to centrifugal force acting on the ball in Newton, M omega square R. So this Fc, M omega square R. So M is this mass, omega square is the speed of rotation around this axis, R is the radius of rotation. So these are the declarations. Something else is also there. T1, T2 are the tension in the arms. Alpha is the angle above and beta is the angle below, between the axis of the shaft. So let's go back and look at alpha and beta. So see here, this is alpha and this is beta because it is a little bit away from the axis. If these two lengths are equal, okay, and both of them are hinged on the axis itself, then the angle will be same. There is no need to say this is also alpha. But here, even though your links have same length or different length, the angle will be different because it is moving a little bit away. Inclination is varying by this much. Clear? Okay. Through the several ways of determining, though there are several ways of determining the relationship between height of the governor and angular speed of the ball, the following two methods are important from subject point of view. Method of resolution of forces, instantaneous center method. I am going to teach you only method of resolution of forces. It's very easy to understand. We may end up using instantaneous center method in some problems. Inevitably, some particular type of complicated problem can be solved only with instantaneous center method. In such problems, when you are doing that, we will tell you whatever is required about the instantaneous center method. That I will tell when you are doing the problem. We don't have to see the entire derivation of instantaneous center method for that. Okay. So we are going to see only the resolution of forces. So method of resolution of forces. Consider the equilibrium of forces acting on the acting at D. We have, where is the diagram? I think you need the diagram to understand this. Let's bring this here. Okay, let's have a look at this diagram and see these things. T2 cos beta equal to W by 2. Where is T2? T2 is here. This is T. So what is T2 cos beta? Right? Beta is here. So let's make a triangle out of this triangle. So now you tell me, when a ball is trying to move outwards and your link is stopping the ball from moving outwards, what what direction will your tension act? It should act like this only. Okay, so your resultant will be like this. Direction of forces. Clear? So therefore, T2 cos beta. So adjacent side is this. T2 cos beta equal to. So look very carefully. So now I am going to just take this one particular link alone and draw it here. You are having a tension in this direction because you have a fly ball which is trying to move outwards. Therefore, your tension in the arm will obviously act in the opposite direction only, trying to stop this ball. Clear, right? So now I am going to solve this into two components, horizontal and vertical. Your vertical component will be like this, horizontal will be like this by triangular law of forces. Beta is here. Now, what is this vertical component called? This is T2. This is T2 cos beta. Correct? So this is T2 cos beta. This is T2 sin beta. Very simple. Clear? Now that T2 cos beta comes from this vertical component of the tension in the lower arm. Clear? With that clear, you will hear T2 cos beta. What else is the downward force acting with respect to this point D? Only with respect to point D I am looking. Okay. So considering equilibrium of force acting at point D. So one force is coming towards point D, T2. That vertical component I am taking. And one more force is W by 2. Why W by 2? Why not full W? So a mass of W weight is sitting here. Okay. So one half of the mass is going to act on this side of the sleeve. Other half is going to act on this side of the sleeve. Clear? So I am going to do only a symmetric half of the calculation. Therefore, I am taking capital W by 2. This is small w. Understand the difference. So this vertical component should be equal to this because they are going to act in the same direction. So therefore, T2 cos beta equal to W by 2. Instead of W, you put capital M into G by 2. So T2 equal to capital M G divided by 2 cos beta. Clear? Again, considering the equilibrium of forces acting on point B. Okay. The point B is in equilibrium under the action of the following forces. Weight of the ball. So this weight. Centrifugal force. Tension in the arm T1. This direction. Tension in the arm T2. This direction. So all these four forces are linked to this point. Are you getting the picture? The ball is here. So centrifugal force. Weight of the ball. Tension in the lower arm in this direction. Tension in the upper arm is in this direction. So now I am going to balance all these four forces by taking components horizontal and vertical. Resolving forces vertically. T1 cos alpha equal to T2 cos beta plus W. Okay, let's look at the upper arm. Alpha is here. Same thing. Your force is tension is in this direction. So cos alpha. This alpha is here because adjacent side will be like this. T1 cos alpha equal to T2 cos beta. T2 cos beta is this one, downward direction, plus W. This is small w. Okay, this is not capital W, this is small w. Okay, weight of this with respect to this point. Don't ask why you have not considered this. It is coming from this point. Okay, now I am going to consider only this point, resolution of forces. So vertical forces, what are the forces acting? This is exactly vertical, so no component, you can directly take it as small w. For this you have a vertical component in upward direction. For this you have a vertical component in downward direction. The tension. Okay. So upward direction and one upward direction force T1 cos alpha equal to two downward direction forces W plus T2 cos alpha, T2 cos beta plus small w. Clear? So from this point, one upward force, two downward forces. I am summing it up. So for equilibrium, they should be equal in magnitude. So from the previous equation which I have derived, I know that T1 cos alpha equal to, T2 equal to mg by 2 cos beta. So if you go to the previous slide, you can see here T2 equal to mg by 2 cos beta. You bring that, okay, and put it here. So in place of T2, I am going to substitute, in place of theta, I am going to substitute mg by 2 cos beta. So why I am doing this derivation, taking all the time, we can straight away go to problems. So there is a twist in the problem. Only if you know how to derive these forces, you can do the problem. Otherwise, you cannot do it. Straight away, formula substitution will not work. You have to know the derivation. Okay. So this is T2 from the previous equation. T2 cos beta. Okay. Plus in place of small w, you have small m into g. Don't confuse small w and capital W. Okay. So again, I am going to cancel this cos beta in the denominator and numerator. So mg by 2 plus mg. So keep that as equation 2. So T1 cos alpha equal to mg by 2 plus mg. Now look at the horizontal forces at the point B. Point B is the center of the ball. So first you have resolved the vertical forces. Now horizontal forces. Fc. So T1 sin alpha and I think it's also in this direction. T2 cos beta, means sin beta, right? So T1 sin alpha plus T2 sin beta equal to Fc. Clear? So this triangle, the horizontal force will be in this direction. Similarly, this small triangle, horizontal force will also be in this direction. Therefore, T1 sin alpha and T2 sin beta are in the same direction. Equal to Fc is in the opposite direction. And balancing the forces. So in place of T2 sin beta, I'm writing in place of T2, you just bring the same expression to this here. So in place of T2, I'm writing this into sin beta, so you can combine this and make tan beta. Right? T1 sin alpha plus mg by 2 tan beta equal to Fc. So T1 sin alpha, send it to that side. So I'm taking this to the right side, RHS. Taking this entire thing to the RHS. So Fc minus mg by 2 tan beta. So divide equation 3 by 2, T1 sin alpha by T1 cos alpha. So whatever results you have derived so far, divide them Fc minus mg by 2 tan beta divided by mg by 2 plus mg. Here, and straight away cancel the T1, T1. So tan alpha equal to, the right hand side is same, no change. Mg by 2 plus 1. I am going to bring the denominator to the left side, cross multiplying. So please listen. Don't think that all these things are not necessary. So cross multiply. So mg by 2 plus mg into tan alpha. You might be asked from part C, you may get this derivation. At that point, you should know how to do this. Okay. So nobody knows what is going to come in part C. Cross multiply tan alpha equal to Fc minus numerator stays there. So send this tan alpha to the right side. Tan alpha in the multiplication. We send it to the denominator of the 6. So Fc by tan alpha minus mg by 2 tan beta by tan alpha. I am splitting the denominator between the two. Substituting tan beta by tan alpha equal to q. So what is this tan beta by tan alpha equal to q? Q is called as the ratio of slope of the two arms. So what is tan beta? You know m equal to tan alpha, right? Slope of a given length is nothing but dy by dx, correct? Dy by dx. So tan beta is opposite side by adjacent side. So this is opposite side by adjacent side. You will get a slope. Similarly, you will get a slope for this. Now, the ratio of these two slopes I am going to call as q. Some factor. Okay. What will happen if alpha is equal to beta? Q will become 1. Clear? If alpha is equal to beta, you can directly cancel this. Which means what? This angle of inclination is same as this angle. In case if it happens like that, that will happen only if both the arms are equal and both are hinged on the axis. Only then it will happen. Clear? It will be specifically mentioned in the question. That is why you have to listen to the derivation. Otherwise, you will not understand it. If both the arms, upper arm and the lower arm lengths are equal, and the lower arm is, both the upper and the lower arm are hinged to the axis of the governor, then this angle will become inevitably same. Q will become 1. So what is significance of this Q we will see now. So tan alpha equal to R by H. So come to this this upper triangle. So what is tan alpha? Opposite side divided by adjacent side. So opposite side is radius of rotation and this side is height of the governor. So I am going to put tan alpha equal to R by H here in this formula. Okay. These two things we change in the above expression. So mg by 2 plus mg equal to, in place of fc I am going to put on m omega square r. So this is fc divided by tan alpha. Tan alpha is r by h. So divided by tan alpha means into h by r, reciprocal, minus mg by 2 into tan beta by tan alpha. I am replacing it as q. So now what you do, you send the whole bracket to the left side. So m omega square r cancel, m omega square h equal to mg by 2 plus mg. This thing is coming to the left plus mg by 2 into q. So now I can take this mg by 2 as common factor for these two things. Take mg by 2 as common factor. So m omega square h is equal to mg plus mg by 2 into 1 plus q. So this mg by 2 and this mg by 2 into q becomes mg by 2 into 1 plus q. Remaining is this mg. Clear? Now send all the other things to the denominator. Just keep the h on the LHS. Just keep the h on the LHS. Send these to the denominator. The same thing is written here with 1 by m omega square on the denominator into 1 by m omega square. So now I am going to pull this m into the bracket. Pull it in. So that becomes, take g as common term outside from these two forms. This also has g, this also has g. You can take it out, bring it out, you bring this in. These are just mathematical manipulation. Don't ask why we are doing this. Because I can substitute the value of g and simplify that into a number. That's why I am taking it out. So, okay. So m plus m by 2 into 1 plus q by m into g by omega square. So in place of omega square, you can put 2 pi n by 60. So send the omega square to the left side and h to the right side. Exchange these two things. Send it to the left side, send the h to the denominator. So you get. So in place of omega square, put 2 pi n by 60 whole square. So now 2 pi 60 squares you bring to the right side as reciprocals. Just n square m. So what did you derive in the what governor? You derived an expression for h equal to 895 by n square. Similarly, I am trying to derive a relationship between h and n here. Okay, n square equal to. So these two things will come to the right side. In square, don't forget the square. Just this n square will stay on the left. We will get 60 by 2 pi whole square. So 60, you know, constant. Pi is also a constant. G is also a constant. Put all the numbers and solve. So we will end up with an answer. Okay. M plus m by 2, small m plus capital M by 2 into 1 plus q divided by m into 895 by h. Clear? This is your final formula for solving Proter Governor problem. Here. Okay. In this, there is a twist here. In case you have a q equal to 1, that is your upper arm and lower arm are having the same length and are hinged on the axis of the governor. Alpha will become equal to beta. What is q? Tan beta by tan alpha. Okay. Tan beta by tan alpha. So q will become 1. So put q equal to 1 here. This will become 2 and this 2 will get cancelled. Therefore, you will end up with the initial formula m plus m by m into 895 by h for a Proter Governor in case you have such a condition. Both the upper and the lower links are having same length and are hinged to the directly to the axis. Most probably the lower one will be hinged offset away on the outside of the sleeve. Okay. Note, when the length of the arms are equal, so this is what I told you, tan alpha equal tan beta, the formula will reduce. What I told you, right? N1 square. In case both the links that are stopping your centrifugal ball are having same length and are hinged directly on the axis of the governor, then this is your formula. You have to read the question properly and understand and then use this formula. If it is not the case, you should not use this formula. Okay. When the loaded sleeve moves up and down the spindle, frictional force acts in a direction opposite to the motion of the sleeve. Okay, so in case you are going to consider the friction between the sleeve and the spindle which is moving. Okay, so let us have a look at this diagram, only then you will understand. What is this friction business? I will tell you. See, once you understand the fundamentals, doing problems will be very easy. Don't feel that I am taking so much of time to take the derivation, why we are doing all this, right? You should understand this. When the sleeve is moving upwards, what will happen? It's going to have some friction at the interface of this mass, this sleeve and the spindle. It's going to have some friction. How friction will act? Friction will always act in a direction opposite to your motion. Correct? So friction will always be acting opposite to the direction of motion. Very simple. Now when your sleeve is moving upwards, when your ball is moving up due to centrifugal force, it is moving outwards and upwards. Your sleeve will move upwards. What will happen? Your friction will act downwards. Correct? It's always opposite. In such case, when your governor speed is high and your balls are lifting upwards, friction will act downward. That can be directly added to the M plus M plus or minus friction divided by M into something, okay, 895 by H or whatever, that formula. So here there is one complication. The unit of M is kilogram, but this is Newton. I cannot directly add it, friction. So to do that, what I am going to do, I am going to multiply G here, making it into force. So I can directly add friction. So M into G, a small change in the formula is done. So we will go back there, then you will understand. When I am going to consider friction, the formula itself will have a plus or minus. You have to decide which is plus and which is minus. So here you see this formula, M plus M by 2 into 1 plus Q by M. Okay. So to add friction directly to the sleeve mass, what I am going to do is I am going to change these masses into forces. How? Multiplied by G, it will become weight. Weight is a force, correct? So M into G. So it will become like this. Now we can directly add the friction. Friction is a force. So M into G is a force. You can directly add. Both are having same units. So mg, small mg plus capital Mg plus or minus friction divided by 2 into 1 plus q whole divided by m into g. Here also the same rule will apply. If you have q equal to 1, then this 2 will get vanished. And that depends on each problem, that you have to read the question carefully. Clear? General formula is here. So m into g, when you have friction, the mass will be multiplied by gravity, so that frictional force can be directly added. If you don't have friction, this g will not be there. This g will not be there. This plus or minus will not be there. That is one thing. Next thing, how do I decide when to put plus or minus? So there, that's what I told you. When your governor is going very fast, highest RPM, your balls will travel upwards, sleeve will travel upwards, friction will travel downwards. What is this? mg. Mg is weight of the central load. How, in what direction your weight will act? Weight will always act downwards. Correct? So when your sleeve is moving upwards, your friction direction and the weight direction are same. So this is your capital W. This is your friction. When your speed is high, sleeve is lifting upwards. Okay, friction will act downwards. So which coincides with the direction of your weight. Therefore, at that case, you have to put plus. The opposite sense, when your sleeve is moving downwards, your governor is slowing down, sleeve is coming down, friction will act upwards. It is opposite to the capital W. That case, you have to put minus. Clear? You have to look very carefully into the problem and decide this plus or minus. Any doubts in this? You want me to repeat how to put plus or minus? When you are doing the problem, again we will see this one, it will become clear. Okay. When q equal to 1, this formula will reduce. That the 1 plus q will become 2. The 2 and 2 we can cancel out. Very simple. The positive sign is used when the sleeve moves upwards, or governor speed increases, and negative sign is used when the sleeve moves downwards, or governor speed decreases. Okay. On comparing the equation of Proter Governor with that of the Watt Governor, so the simplest form of Proter Governor, where q equal to 1, your formula is m plus m without friction. Okay, m plus m by m into 895 by height of the governor, n square equal to. So what is the formula for watt governor? This is the formula for watt governor, 895 by MC. So your sleeve, the speed of your governor, the relationship between your speed and the sleeve lift of a Proter Governor is proportional to your watt governor by this ratio, small m plus capital M by small m. So that is the note. Here, that completes your Proter Governor derivation taken from section 18.6 of your Kurmi text.